Not the altitudes, that was the Ortho Center. Centroid was the, oh, that's fancy. The medians, yes. So when you draw three medians, remember this is a midpoint to an opposite vertex is a median, okay? Yes.
What's a median?
From the midpoint of a side, so like E is the midpoint down here, connected to the opposite vertex, so connected to B. So this orange line is a median. Okay, this is the super cool thing about medians, centroids really. If you take three medians and you draw them, like you see here, the centroid is always 2/3 of the distance from vertex to midpoint. So this point right here works out so that this is 2/3 of the segment and this is 1/3 of the segment. Same thing the other way. This would be 2/3 of the segment and this is 1/3 of the segment. And the last one, 2/3 of the segment and 1/3 of the segment. Okay, so if you look at example 1 here, I'm going to give you a couple more letters. Call this point here F and this point over here G, because we're going to do more than just what the question says to make sure that you're getting it. Okay, so with a centroid, 2/3 and 1/3 come into play a ton. If I tell you that DE is 6, okay, so this piece right here is a length of 6. That is 1/3 of segment BE. The other piece of BE, BD, is 2/3 of the segment. So if 6 is 1/3 of the segment, how long is 2/3 of the segment? It's twice as much. It's 12, right? If this is 1/3, then this is 2/3 or 12. So BD is a length of 12. So BE is 6 and 12 put together, or 18. Do you see that? 2/3 and 1/3. Okay, I'm going to erase all of this. So we have a clean slate to work from. So we said this was 6 and this was 12. What if I tell you that this is, that this is 8? DC is 8. What is FD?
4.
FD would have to be half of that, or 4. So if I know the bigger piece, the smaller piece is half of it. If I know the smaller piece, the bigger piece is double it. What's the whole thing? What is FC?
12.
FC is 12. Okay, now this one's different. Stop and think about it for a minute here. If I tell you AG is 15, AG is the whole thing. What is DG?
The whole thing. No, that'd be not half of it.
Not half. 5, right? So if I give you the whole thing, you have to divide by 3, right? It's 1/3. 1/3 of 15 is 5. Okay, so this would be 5. So then what is AD? AD would have to be 10. Then you double it. Okay? So just keep that in mind. If I give you the whole thing, divide by 3 and you'll get thirds. If I give you the shorter segment, double it and you'll get the longer one. If I give you the longer one, cut it in half and you'll get the shorter one, because it's always 1/3 and 2/3. Okay? Okay, the Ortho Center is the point of concurrency of the altitudes. So that's the last thing we were just constructing. Remember, this is perpendicular through a vertex to the opposite side. Okay, that is an altitude. So I want you to look at this picture, and I want you to tell me where you see a perpendicular bisector, an angle bisector, a median, and an altitude. So perpendicular bisector, angle bisector, median, and altitude. And when I drew this, they were all color-coded, and now you really can't tell the difference between green and blue and between orange and red. So I'm going to give you letters instead, okay? So here's your letters. Gentlemen, you don't need to talk to each other. Why don't you just move away? So let's say that's A, that's B, that's C, that's D, and we'll call this E. Okay? Knowing what we know, let's start with the angle bisector. Which segment is an angle bisector right here?
D.
What is it?
D.
D is not a segment.
C.
C is not a segment. CE would be an angle bisector, right? These markings show us that those angles are congruent for this line. Okay, so the angle bisector here is CE. Can you tell me the median? And just to clarify, these two are the two pieces that are congruent with those congruent markings. So B is the midpoint.
Okay.
So what is your median?
B.
B is your midpoint.
Is it C?
EB or BE, right? The segment that goes from the midpoint through the vertex of the opposite side is your median. Okay, BE. Okay, now perpendicular bisector and altitude are both perpendicular, but they're different. One has to be a perpendicular bisector, so through the midpoint. One has to be through the opposite vertex. Which one is the perpendicular bisector? AB, yes. AB would be the perpendicular bisector, and that makes the altitude ED. Okay, it's perpendicular, but not necessarily through the midpoint. Questions on that?